In our lesson today, we're going to be investigating identities and inconsistent equations. We'll start off with the equation 8 times in parentheses k minus 6 plus 58. That'll be equal to 2 times in parentheses 4k plus 5. It says to determine if the following numbers are solutions to the equation by using substitution. So in the first example, all right, x, these all should actually be k's since that's the variable that I've used up here in the equation. I'll just change all of those to k's. K is going to be equal to 2. So every place that I have k in my equation, I'm just going to replace it with 2. So I'm going to have 8 times in parentheses 2 minus 6 plus 58 equals 2 times in parentheses 4 times 2 plus 5. All right. So, following order of operations, I'll evaluate in the parentheses. First, here on the left, 2 minus 6 is negative 4. So we have 8 times negative 4 plus 58 equals 2 times in the parentheses. I'm going to multiply first. 4 times 2 is 8 plus 5. On the left, I'll now multiply 8 and negative 4 to make negative 32 plus 58 equals 2 times in parentheses. 8 plus 5 is 13. And now when I evaluate the left-hand side, negative 32 plus 58 makes 26. And 2 times 13 on the right is also 26. 26 equals 26. So k equals 22 is a solution. Yes, k equals 2 is an answer to the problem. What about when k equals negative 1? So just like I did before, I'm going to substitute a negative 1 for my variable. 8 times negative 1 minus 6 plus 58 equals 2 times 4 times negative 1 plus 5 in parentheses. On the left-hand side, in the parentheses, negative 1 minus 6 is negative 7. So 8 times negative 7 plus 58 equals 2 times 4 times negative 1 is negative 4 plus 5. 8 times negative 7 is negative 56 plus 58. Negative 4 plus 5 is 1, so this is going to say 2 times 1. Negative 56 plus 58 is 2, and 2 times 1 is 2, so 2 equals 2. K equals negative 1 is also a solution to this equation. What about when k equals 5? Let's go ahead and substitute. 8 times 5 minus 6 in parentheses plus 58 equals 2 times 4 times 5 plus 5 in parentheses. On the left, 5 minus 6 is negative 1, so 8 times negative 1 plus 58 equals 2 times. 4 times 5 is 20 plus the 5. 8 times negative 1 is negative 8 plus 58 equals 2 times. 20 plus 5 is 25. Negative 8 plus 58 is 50. 2 times 25 is 50. 50 equals 50. So k equals 5 is also a solution. Which values above are solutions? Well, we just did the substitution and we found that all of them are solutions. Okay, every single answer that I had up above, k equals 2, k equals negative 1, k equals 5, those were all solutions to the equation. So in example 2, it says to simplify each side of the equation. I'm not going to substitute anything in. I'm just going to do my use my distributive property here to start, and I'm going to simplify each side as far as I can. 8 times k plus 8 times negative 6 plus 58 equals 2 times 4k plus 2 times 5. 8 times k is 8k. 8 times negative 6 is negative 48 plus 58 equals 2 times 4k is 8k, and 2 times 5 is 10. On the left, negative 48 plus 58 is 10, so we have 8k plus 10 equals 8k plus 10. Look at that. Each side simplified to the same expression. Example number 3. What do you notice? All right, well, we just said that each side simplifies to the same expression. All right, we had 8k plus 10 on both sides. So the question wants to know then, how many solutions does this equation have? How many values could we plug in for k where we would get the same answer? Well, since the two sides are equal to each other, 8k plus 10 equals 8k plus 10, I can plug any number in for k and I would get a true statement every single time. Okay, so this means that there are infinite solutions. Any number that I substitute in for k is going to be a solution to the equation. Okay, so here, the equation above is an example of an identity. This means that any value that you substitute in for x will make the equation true, meaning that there are infinite solutions. Whenever you get an identity, there will be infinite solutions. So if I simplify each side of my equation and I end up with the same thing on both sides, I know that I'm working with an identity and there will be infinite solutions. So we just found out that if we simplify each side of the equation and we get the same expression on each side, that's going to lead to an identity, meaning that there are infinite solutions. In example 4, it says determine if the following equations are identities. You do not have to actually solve the equations. All right, so what I'm going to do for each one of these equations is simplify each side as far as I can, and then I'm going to look and see if I've got the same expression. In letter A, I'm going to first distribute the 8 to everything in the parentheses. 8 times x plus 8 times 2 equals, on the right, well, there's not really anything to do here. That's just going to be 2x plus 16. And on the left, 8 times x is 8x. 8 times 2 is 16. 8x plus 16 equals 2x plus 16. These expressions are not the same, so this is not an identity. In example B, again, I'm going to distribute the start here on the left. 2 times 3x plus 2 times 3 equals, on the right side, distribute the 3. 3 times 2x plus 3 times 2. On the left, 2 times 3x is 6x, and 2 times 3 is 6, so we get 6x plus 6. And on the right, 3 times 2x is 6x, and 3 times 2 is 6, so I also get 6x plus 6. These expressions are the same, so this is an identity. That means that there would be infinite solutions to that equation. In example C, we'll start by using the distributive property, 6 times x plus 6 times 1, and then bring down plus 5, equals 13 minus 2 plus 6x. Well, I can actually combine my similar terms here. 13 minus 2 is 11 plus 6x. And now on the left, 6 times x is 6x. 6 times 1 is 6 plus 5. The right side can't be simplified any further, so we have 11 plus 6x. And on the left, if I do 6 plus 5, that is 11. 6x plus 11 equals 11 plus 6x. Remember that addition is commutative, so I could reverse the order. 6x plus 11 equals 6x plus 11. It's the same expression on each side, so this is also an identity. In letter D, 10m minus 2m minus 3 in parentheses equals 5 times 2m plus 1 in parentheses minus 3m plus 4. On the left, I have this negative, and it's really a negative 1 that I'm going to distribute here. So I'm going to have 10m. Negative 1 times 2m is negative 2m. Negative 1 times negative 3 is positive 3. Equals 5 times 2m is 10m. 5 times 1 is 5. Minus 3m plus 4. On the left, I can combine my similar terms. 10m minus 2m is 8m plus 3 equals, on the right-hand side, 10m minus 3m is 7m, and 5 plus 4 is 9. So we get 8m plus 3 equals 7m plus 9. These expressions are not the same, so this is not an identity. Okay, if you simplify each side of the equation and you get the same expression, then you will have an identity. In example 5, it says to solve each equation below. Letter A, we have 2x plus 3 equals 2x plus 7. I have a variable term on each side, so I'm going to get my variables on one side first. So let's subtract 2x from each side. All right, bring down your equal sign. 2x minus 2x is 0, leaving us with 3. And on the right side, 2x minus 2x is 0, leaving us with 7. And now my equation says 3 equals 7. And there's really not anything else I can do. All right, 3 isn't equal to 7. And I can't really move anything else from one side to the other. So there it is. 3 is not equal to 7. All right, how about letter B? 3 is multiplying x plus 4, and that equals 3x plus 11. Let's distribute 3 times x plus 3 times 4 equals 3x plus 11. That's going to give us 3x plus 12 on the left side equals 3x plus 11. And again, I've got variables on each side. Let's get them on one side. We'll subtract 3x from each side. 3x minus 3x is 0, leaving us with 12. And 3x minus 3x is 0, leaving us with 11. Uh-oh, this is just like over here. 12 equals 11. That's not true. And there's really nothing else that I can do there. All right, so I got 3 is not equal to 7, and 12 is not equal to 11. Each equation above gives a result that is not true. These are called inconsistent equations, meaning that there isn't a value that you can substitute in for x that will make the equation true. There is no solution to either equation. It doesn't matter what value of x I try to substitute in, I'm not going to get anything where they're going to be equal to each other. Okay, if you notice, the variable terms here are the same, but the constants are different. Okay, same thing over here. Once I had after I distributed, I had 3x on each side, but the constants were different, meaning that I'm never going to be able to make an equation that is true. An inconsistent equation has no solution. Okay, so in the last part where we simplified each side and we got the two expressions to be the same, that's an identity, meaning that there's infinite number of solutions. But if I get a statement that isn't true, inconsistent, no solutions there, okay? The variable terms are the same, but the constants are different. So what if we get an example like this one here in question 4a? All right, on this side, the variable terms were different. All right, when the variable terms are different on each side, that means that there will be a solution, but only one solution. Same thing down here in letter D. 8m plus 3, 7m plus 9. The variable terms are different, meaning that there will be one solution. Okay, so what we should be able to do now is recognize if an equation has no solution, one solution, or infinite solutions. In our next example, we're going to determine if the equations have no solution, meaning that it's an inconsistent equation. Do they have one solution, or do they have infinite solutions, which would be called an identity? Now, once again, we're not actually going to solve these equations. We're going to simplify each side until we can figure out if there's going to be no solution, one solution, or infinite solutions. So let's start in example A. 4 is multiplying x plus 3, and then we're subtracting 4, and that equals 8 times half x plus 1 in parentheses. Let's distribute the 4 first. 4 times x is 4x. 4 times 3 is 12 minus 4 equals 8 times 1 half x. Half of 8 is 4, so that's going to be 4x. And then 8 times 1 is 8, so we get 4x plus 8. On the left side, 12 minus 4 is 8, so we get 4x plus 8 equals 4x plus 8. Notice that the expression is the same on both sides, which means that this is an identity. Therefore, there are infinite solutions to this equation. Any number that I plug in for x will be a solution. Letter B. All right, we've got a whole lot of distributing that we're going to do here. Let's start on the left. 2 times 3m makes 6m. 2 times 1 is 2, plus 3 times m is 3m, and 3 times 5 is 15. Equals, bring down that 4m, and then 3 times m is 3m, and 3 times 1 is 3. All right, let's simplify each side now. On the left, 6m and 3m makes 9m, and 2 plus 15 makes 17. And on the right, 4m plus 3m is 7m, and then there's nothing to combine with the 3. 9m plus 17 equals 7m plus 3. These are not the same expression, and the variable terms are different. 9m and 7m are different from each other. This means that there will be one solution to this equation. Okay, I could subtract 7m from each side and then subtract 17 on each side and then figure out what the value of m is. Example C. Okay, on the left side, I have 3x plus 7x, which would make 10x plus 1 equals, on the right-hand side, 2 times 5x is 10x, and 2 times 1 is 2. And both sides is simplified. There's nothing else I can do. Now, 10x plus 1 is not equal to 10x plus 2. The variable terms are the same, but the constants are different. So if I were to subtract 10x from each side, I would end up with 1 equals 2, which isn't true. This is an inconsistent equation, so there is no solution. There's no value of x that I would be able to substitute in. Finally, on letter D, let's distribute first. 4 times n is 4n. 4 times 1 is 4. 2 times n is 2n, and 2 times 3 is 6. And on the right side, bring down 11n. This again is like a negative 1. Negative 1 times 5n is negative 5n. And negative 1 times negative 2 is positive 2. And now if I were to combine the like terms on the left, 4n and 2n make 6n. 4 plus 6 makes 10. 6n plus 10. On the right-hand side, 11n minus 5n makes 6n, and there's nothing to combine with that, 2. And then if we subtract 6n on each side, our equation says 10 equals 2, which is not true. This is an inconsistent equation as well, which means that there is no solution. No solution to that equation. In example 7, it asks how many values of x will make the rectangle and triangle have the same perimeter. Okay, remember that to find the perimeter, you add up all of the sides, and we want the perimeters to be equal in this example. So let's start with the rectangle. Okay, remember that with a rectangle, opposite sides are the same. So the bottom is 2x plus 3, so is the top. The right is equal to x, so is the left. All right. And with a rectangle, to find the perimeter, you can do 2 times the length and 2 times the width. Okay, so if we call the length 2x plus 3, 2 times that entire length, 2x plus 3, plus 2 times the width, which I've called x, 2 times x, which is just going to be 2x. Right? This expression represents the perimeter of the rectangle. We want that to be equal to the perimeter of this triangle. Notice that all 3 sides are 2x plus 2. This is an equilateral triangle. When all sides are the same, I can multiply the length of one side, 2x plus 2. That entire expression I can multiply by 3 because all 3 sides have the same length. So let's see how many solutions of x we can get where these two perimeters will be the same. On the left, we're going to start by distributing. 2 times 2x is 4x, and 2 times 3 is 6. Bring down plus 2x equals. On the right, 3 times 2x is 6x, and 3 times 2 is 6. On the left-hand side, I can combine 4x and 2x to make 6x, and then I can bring down my constant of 6. Equals 6x plus 6. Each side is simplified as far as we can go, and notice we get the same expression. 6x plus 6 equals 6x plus 6. So this is called an identity, which means that there are infinite solutions. Any value that I substitute in for x in this example would give us the same perimeter for the rectangle and the triangle.